All right, everyone join the Zoom call. I linked it. All right, we have 11 people in here. 13 people in this session. Just waiting a little bit longer for a couple more people to join. Yeah, anyone who's not already in the Zoom call, the link is in open session voice text. Please join there. And then does everyone have Reckful open as well? Guess we can. Yeah. All right, looks like we're just missing one right now. All right, looking good. Everybody's in. Oh, and then we got one more. All right. Hello, everyone. I'll mute on Discord. Hang on. Can everyone still hear me?
Yeah,
Okay.
we can.
Awesome. Okay, hello everyone. How's it going? Man, everyone sounds really excited to be here.
I'm trying to help my brother with something. You can go now.
No problem. All right, so I mean, if everybody here, I mean, looks like everybody here is from like session 3. So, I mean, I'm not really sure that we need to do any kind of introductions here, especially since we have the same teachers as last time too. So, we can probably just jump on in.
One says he's new.
Oh, hang on, I don't have my chat open. Where on earth is the chat? There we go. Okay. Oh, hello, Luffy. You're new here? Cool. If you want to give a brief introduction, you can. It's not required. We can kind of. Yeah, go ahead. Yeah, you can just kind of say like, I mean, why you want to learn coding, basically. But if you don't want to, that's fine. It is pretty popular nowadays, yeah. Meeting pass. Yeah, man. Lots of people here are here because coding is getting pretty big right now. Actually, it's been big for a while, and it's getting even bigger. I hope most people that are here will love programming once we're done. That is the goal, after all. So we're just. Oh, the password. Oh, yeah. Okay. Yeah, I haven't had to put in the password at all.
It's weird. It filled in automatically for me yesterday.
Yeah, that's weird. I haven't even like seen that there was like a place to put a password because it just like does it for me.
Yeah.
Hello.
Hey,
Hi.
we have 15 people now. So this class is still going to be kind of general, like a little bit targeted at beginners. Wait, am I muted?
No,
Can Exa, can you hear me?
I can.
Yeah. Wait,
Oh, yeah.
Anybody hear me?
Exa, are you in the Zoom call? Okay. Yeah. Okay. All right, we're looking pretty good to start here.
So what about functions are we learning today?
We're learning everything about functions. So we're starting from the bottom though. So essentially like what a function is, how to use a function, how to make your own functions.
Okay. And then what the different types of function are we gonna make? Are we gonna make the one that calls itself back?
We won't we're just gonna be doing really basic stuff. So we're not gonna be doing any kind of recursion. We're not gonna be doing much like passing functions as parameters. That's all kind of advanced stuff that it's going to be pretty difficult for a beginner to be able to grasp those ideas from the very beginning.
Okay.
So in general, this class is targeted at beginners for right now. When we get like several more lessons deep, we'll be learning a bit more advanced topics.
How about those tasks?
Yeah. So I mean, if it doesn't, if it's not good for you, then you don't have to come. Like it's fine. And we'll always like cue everyone in, like kind of what the general idea of next lessons are when they're coming out.
I've already learned C++. I'm just here to learn the Python language from scratch. So yeah. So I'm enjoying these classes because it allows me to learn the language in a fun way. Because my previous attempt at learning Python was just okay. I feel like very comfortable with C++. Python is based off C++. Python was so easy. I jumped straight into Discord.py, and I was immediately confused. And yeah. and I sort of had this block of finding it hard to learn the language on my own, or trying to put in the effort to learn the language on my own, because I felt like I already know how to program. So, but these classes are making it easier and more enjoyable.
Mm.
So yeah.
Well, cool. So, I mean, that's generally what we're doing here. So for everyone, we will be using there's a participants menu on Zoom, which has a raise hand function. We'll be using that for like when we do exercises, you raise your hand when you're finished. For anyone that is not already aware of the raise hand function. And then we'll also be using the Zoom group chat. I won't really be able to monitor the Discord chat too much while we're in here. So just so you know, we'll zoom in a little bit here and we will get started. All right, so if you have any questions at any time, you can just post them into the chat. Exo will be watching the chat probably a lot more carefully than I will. I'll be kind of focusing on the lesson, I think. So you can also feel free to just like shout out your questions. Like, I don't mind getting interrupted. Just don't scream. Okay.
Sounds good.
All right, so let's get started. So first, the main question is like, what's a function? So it's not really like anything that we've done before, but we have already used some functions in previous lessons. So as with, if you had a list, so if you had a list like this, then we've used the like list.append. This is a function, right? So, oh, this is there. Okay, so when you have a function, essentially it's like a named thing that can accept what's called arguments. So arguments are what go between the parentheses. Functions can accept, well, they are defined to accept a certain number of arguments. And when you have a nice text editor like this one, it will tell you like what the arguments are supposed to be. So object is what we're passing as the argument here. And it kind of gives you some information about like what that means, what argument means here. And so you can like add anything into the list like so. But we've already seen that and that's boring. So we're gonna make our own functions. So in order to make a function, to create one, you can say def. So def is a keyword here. And then you follow it with the function name. So in the case above, the function is named append, but here we're just going to be naming one called calc, kind of like calculate. So, and then if you want to specify some parameters for your function, as in these are things that your function can take as input, which I'll kind of explain it a little more in depth coming up here. Then you can just specify them as names. So these are just variables that your function can use. And when somebody's calling your function, then those variables get defined based on what they pass in. We won't be using any types here. We're kind of avoiding types. We're using just the dynamic typing of Python. So we'll just start off with A and B as our parameters. And then you finish the function. This is called the function signature. And you finish the signature with a colon. And then when you go to the next line, we'll be making the function body. So the body is the logic. It's what happens like after you call the function. So when you call list.append with ABC, you're assigning ABC to the first parameter of append, and then it runs the function body of append. So here we'll be making the function body for calc, which is just going to be something really simple. We'll create a result, and we'll make it just A plus B. And then we can return that result. So the function body here is both of these things, and it's denoted by the indent. So the indent tells you that you're inside the function. So this return statement, return means essentially when you call this function, it's I don't know how to describe this without saying return. So when you call the function, you can assign it to like a variable or something, right? So you could say k equals l.append. So l.append doesn't actually return anything, but if it did, then it would be assigned to k. So for functions that don't return anything, it's assigned the value none. None is a special character, or it's a special value. But if we do return something, then the function, we can return whatever we want here. So for example, we can call this function. We can say results. Well, we'll use something different. We'll say r. R equals calc. And then we need to pass a and b here. So these can be anything that can be added together, but we'll use numbers. So 20 and 2. And then we can print that result. If we run it, oops. Oh, sorry. Wow. Crazy. All right, then we'll see 22. All right, so does everyone kind of follow what's happening here? So when we call calc, it essentially runs this code, but it runs it right here.
So there's no curly braces, right? It's just defined by the indentation. And then
Correct. Yeah. Python doesn't use any curly braces for any kind of code blocks.
it's a brave new world.
Exactly. Oh, you can meet on Discord as well, because we're getting kind of an echo from you. Okay. So yeah, literally when you call a function, which you call a function by using the parentheses, and then you pass the arguments. The arguments are assigned in order. So 20 is A and 2 is B. And then the function body executes. And so it'll perform all of this code using the assigned values for these variables. And then return means literally returning this value. Oh, sorry. What was that? Could you say that again? Oh, okay. No problem. So when you say return, you're literally returning whatever this value is as like the value for this expression. So R becomes the result of calling this function, which is just whatever you return. Okay. So now that we've made this function as an exercise, we'll make a new function where just make a new function that can divide two numbers. So I'll give you a little bit of time. Just raise your hand when you're finished using the raise hand function. It's not a function like we've been talking about. Yeah, so division operator is the slash.
And when you're done, simply use the raise hand thing so we know that you're done.
I'm gonna go to the bathroom really quick, actually.
Good luck. And once you guys make your function, you're more than free to call it like TB did for the addition function and see if it actually works as you expected it to. By printing the result, that is.
All right, I can see about half of the people are finished. If you're confused, shout out. All right, so is R somehow associated with result? So no. So R is not results. They are not the same thing. Result only exists inside of this function. When you return result, you're returning the value of it. So in this case, result is whatever A plus B evaluates to. And so when we return it, we're just assigning it to a new variable. We're creating this variable R at this point. No problem. Yeah, so I guess something I didn't really mention that is important is that when you're inside a function, anything that you define is, you can only see it when you're inside this function. If you leave the function, like these things are not visible anymore. Like we actually cannot use results here. You'll see it's underlining it because it doesn't exist, right? And so if we run this, we'll get an error. Result is not defined. And the reason for that is because of something that they call function scope. So scope is generally like the area where variables are defined. And so when you have something called function scope, it means that variables that are defined inside functions are not visible outside of the function. Exactly. We use return because it lets us get a value, like some kind of result out of any function call. Extremely useful. So functions help us do lots of things, and one of those things is preventing cluttering up of your like variable names. So imagine we had like a file which was, you know, like 1,000 lines long or something. Like the amount of variables you'd be using just goes up and up as your file gets bigger. And like all of those names are kind of global inside that file. But if we use functions, then those variable names are only local to the function itself. So outside the function, the variable is not visible anymore. So it kind of packages your code, and it also like keeps, oh, what'd I do? Oh no. I think I just closed my REPL. 1 second. Okay, wow. Awesome. Technical difficulties indeed. All right, so we'll just do this. Okay, yeah. We're back. Okay, so it looks like most people are finished. Is anybody like completely, oh, I'm no boomer, man. So is anybody completely lost? We're about to go over it. So okay. All right, if nobody's speaking up, I'll just kind of assume that everybody's kind of got it to some extent.
I'm good.
I have an issue.
You can feel free to use Reckful as well. I linked it in the open or in the chat on the Discord chat. It'll make it a little bit easier to get started. Okay, so I'll give an answer here. So if we define a new function for dividing two numbers, first we have to use def, and then we have to pass the function name. So you can name it whatever you want, right? So we're gonna call it div here. And if it needs to divide two numbers, then we'll need two parameters. So we'll do A and B, again, like before. And then the colon. And here I'll skip the variable assigning step, and we'll just straight up return A divided by B. And this is it. This works fine. So we can show that by saying, we'll do div, sorry, we'll print div, we'll divide 10 by 2. Let's print that out. Yeah, so when you divide 10 by 2, you get 5.
Now, why did it add the or 0?
Oh, so the reason for that is actually the division operator itself. So when you divide two numbers, it's going to convert it into a float.
Okay.
And so whenever you print floats, it always prints it with the decimal place, just to let you know that it is actually a float.
Gotcha.
Fun fact, there is an additional operator called integer division, and you just do 2 slashes. This will divide as if both numbers are integers, and this can have interesting results because when you're talking about integers, there's no decimal place at all.
Mm-hmm.
And so if you divided, say, 1 by 2, oh, not like that. If you divided 1 by 2, then you would actually get 0 because 2 does not go into 1.
Mm-hmm.
So it's treating them both as integers, and the remainder is ignored. So
cool.
Fun. Little fun fact there. Quotient. So quotient is the result of a division. Remainder is what's left over when you attempt to divide. So if you divided like 2 by 4, not even. So if you divided 2 by 3, so 3 doesn't go into 2, right? But there will be 1 left over if you try to put 3 into 2. So your remainder is 1. So you can get the remainder as well with modulus. But anyway, we're getting a little off topic here. So let's see. Now we're going to talk about, you can do default arguments. So given a function, which, oh my God. All right, so given a function that we can create, so we'll just call it calc again. We can provide as many arguments as we want, right? But let's say we have like a lot of arguments, and so we want to make some of them like defaults. You can do that by saying equals and then passing a value to set it equal to whenever you call the function. So in this case, we can call this function while passing only a and b. And then it'll default m to 1 and e to 5. So this sounds kind of silly, like we could just use those in the function body, right? So let's do a plus b times m plus e. So if we do this, some people might think, well, why don't we just do 1 plus 5? And then that's the same as defaulting it, right? Not exactly. The reason for that is because you don't, it's a default argument, but it's not, like you can still pass it if you want to. So we can call calc with just like 2 and 8. We can also call calc with 2 and 8 and 2 and 0 if we want to. And so if we do that, like in the first one, we're using both of the default arguments. So m is 1 and e is 5.
You can't just print result.
Hmm?
You can't just print result
Oh,
because
yeah, you're right. Well, let's just do it like this. Yeah, so in the first one, we can default them here. In the second one, we can override them. And so we'll see the result of that. So in the first one, it's 2 plus 8 times 1 is still 10, and then plus 5 is 15. And then in the second one, we call 2 plus 8 times 2, so 20, plus 0, still 20. Does this make sense to everyone? Using default arguments. So the usefulness here kind of seems arbitrary, but in other use cases, this could be a very different idea. So we can also mix it up a little bit. And let's say we only want to provide one of them, but we only want to provide E. So E is the fourth, but we want to use the default for M. So we can provide A and B like normal. So 2 and 8. Oops. But then we don't want to provide M. We just want to use the default. So we can do that by specifying E directly. So here we can just say E equals, and then we can pass something. So just 0. So in this case, M remains the default of 1, while E gets overridden with a new value. My Discord is getting blown up. I need to mute this for right now. Okay. Right, so when you have a parameter that has a default, some people will call this a keyword argument. So it has a keyword, which is the name of the variable, and it's already assigned a default value. So we can initialize, declare a variable, make it an argument at the same time. Yeah, so this is basically declaring it, or we're initializing it with a default value. E equals 9? You mean this E equals 0? Yeah. So here we're specifying that we're just calling the function like normal, and we're passing arguments like normal until we get to the E. So at this point, we're using E as a keyword argument. We're saying, like, specifically we want to target E here, and we want to make it 0. So this time we're not passing M. The reason we can do this is because E has a name, or it has a default value. I don't believe you can do this with, you can't do this with like the regular variables, like your regular parameters. You can only do this with ones that you have like specified a default value for. Like these are inherently different than the other types of arguments. You can do a couple extra things with them. Okay, and then you can also kind of do the same thing, except you can just pass M equals something as well. So note that these don't even have to be in order. So when you're specifying arguments using their names, they can be in any order you want. You just have to pass them. Yeah, Dario. Yep. You're missing a parenthesis, but yeah, that's correct. Okay. So if we run this last one, then it'll assign M as 0.6 and E as 0.2. Even though the order when we defined this calc function is actually M and then E, we are specifying E and then M. The reason we can do that is because we're using the names, right? So the order doesn't matter anymore once you use the names. And we get 6. I don't know if I want to do this exercise, actually. What do you think, Exa?
Wait, I don't have the ripple up. Give me a second.
It's find a combination of arguments that results in 6.5 without using E.
Yeah, go for it. Why not?
Sure. Okay. So we'll do an exercise here. So using our existing calc function, can you guys find a combination of arguments that results in an answer of 6.5 without using E? So only using A, B, and M.
Using the function that you've created, right?
Yes, this calc function that we've been using.
All right.
So A, B, M equals 1, E equals 5.
What value did you say it should equal?
It should equal 6.5. So
Cool.
Diego says, so what does result exactly do? Confused since you can do the same thing with print and calc. You can. I'm just kind of illustrating that you can do it either way. Oh yeah. Yeah, so something PyCharm will do for you is it'll give you automatic highlighting based on something called PEP8. So PEP8 is a style guide. They made it like a long time ago for Python, like the creators did. And so essentially, PEP8 is like, this is how you should write Python code. Like when you write Python code, it should look like this. No, it's absolutely accurate. Like if you write code like that, it promotes like writing consistent code with like what other people would be writing. So obviously not everybody's going to follow it because not everybody uses PyCharm, not everybody cares, etc. But it's kind of like a guide, like this is what Python code should look like. So theoretically, if everyone did it this way, all Python code would be readable and usable by anybody. Because oh, so in Python, you should always be specifying in snake case is what they call it. So ABC 1, 2, 3 elemental P. Always use underscores between your. Yeah. Yep. Yeah, so when you guys are finished, go ahead and raise hand in the participants tab. And I use Pascal case. Oh, it's a kebab case, yeah. How to use decimal numbers? When you specify the decimal place. So like in this example, we have 0.6. Yeah. Yeah, I think there's like a full subreddit for like I don't know if it's a subreddit for this, but like languages that you can use like all caps in, like everything all caps. People are like really into that or something. Yeah, for constants, it's like the typical thing. But in Bash, the typical way for creating variables is all caps. But there are some languages where the case of the keywords doesn't matter. And so you can make it all uppercase. You can make all your variables uppercase and you can make all the keywords uppercase. Mm-hmm. Definitely. Peef, there's already a coding language out there that does that. It's called Scala. Scala is awful. Yeah. Scala is functional. So basically it's like it runs on the JVM. So it runs on like Java bytecode, or it compiles into Java bytecode. But it's like functional and it's like really type safe. And so I don't know, like, oh, does it really? I actually didn't know that. I didn't. I mean, I guess you can probably compile Lisp into that, but I'm not sure that it does that by default. Are floats in Python a fixed width? No. But yeah, in Scala you can overload operators, and you can make your own operators. So like any combination of symbols that you can imagine, you can turn that into a function. And so yeah, obviously it just becomes like ridiculous after some amount of time, right? So at some point I had to, for work, I was supposed to do, we were gonna like make some external API call. And so I was like looking up, oh, how do I make an HTTP request in Scala? And I found this thing, and it was called the periodic table of operators for HTTP. And I'm just like, at this point, you've gone too far. Right? Okay, we'll move on from this now. So what's the answer? Does anyone know it? Nope. Totally lost. 0, 5, and 0.9. Does that really work? Let's find out. I got 9.5. But we're looking for 6.5. Oh, whoops. I'm dumb. I didn't use m equals. Or it was supposed to be e equals, yeah. Well, it still only makes 5.9.
No, it's with m equals. We're trying
is
to not
it?
use e.
Oh yeah, that's right. Wait, then it should just be like this, right? Sorry, I didn't get like a ton of sleep last night, so I'm a little loopy today. Well, it looks like I have the answer here. And you guys are all doing crazy complicated ones. It's 1, 2, and 0.5. A little bit simpler. All right, so let's keep moving, since I took probably too long of a break for that. All right, let's see. What are we on next? All right, so whenever you call a function, it returns a value. So values can be used, I mean, just like you can use like 3 plus 4. So 3 is a value, 4 is a value. If you do results equals, and let's make some functions first, actually. So make def add a and b, and we'll return a plus b. Remember, these are like really arbitrary, like really ridiculous functions. Like you wouldn't actually make functions like this. It's just for illustration purposes. So if you made a function for adding and a function for multiplying, you can use the return values just like you can use like 2 plus 4. So 2 and 4 are values. In the same way, add 2 plus 2 is a value, and multiply, let's do 2, well, let's do 7 and 2 is also a value. And so results here is just the result of adding 2 and 2, and then adding, add 2, 2, plus multiply this, right? So these are all just values that you can use. Of course, I keep doing this. So 18. So we can also, because functions return values, we can also say result is equal to multiply. And for the first argument, we'll just call a function here. So we'll say 2 plus 2. And then we'll multiply it by 7. And then we'll print it. So functions here are still values. You can use them in any place that you can put any other type of value. And the value of the function is always determined by which return statement ran. Okay. All right, so, oh, you got a question? Yeah, go ahead. Enforce? No. There's a way to specify it, but it's called type hinting. You can look it up, but we're not going to be going over that right now, kind of out of scope for the lesson. So it depends on if you add a decimal place or not. So a number without a decimal place is always an int. And then when you add a decimal place to it, it becomes a float. What do you mean defaults? (1.2), yes, would be a float. Not sure. Not sure. They have a decimal type, which is actually like a class. So you can't exactly use it as easily as built-ins. But it has like really like even longer precision than a float. Can you define something multiple times? You can redefine something, but it'll overwrite the old value. So as we've been redefining result all the way through this file, results, its old value keeps getting like overwritten with the new value. Okay, and so we're actually going to redefine something here now. So we'll say def calc is a, b, m equals 1, e equals 5. Just like before. We'll follow the style guide this time. So we'll do it just like before, except this time we're going to use our new functions that we built just up above inside here. So before we were calling it, we were doing the actual mathematical operations here. But just to illustrate that other functions are accessible inside this function, we can say added equals add. We'll add a and b together. Whoops. Why is it? Oh. So we can do this. We can multiply. And then we can add the two results together. Or we can add e to the end of it, sorry. And then we can just return that result. Okay, so this function is exactly the same in terms of functionality as this one here. So the one we were using earlier. So these two functions do exactly the same thing. And we can see that by calling it with the same arguments, and we'll get the same results. So let's see. Here we called calc with 1, 2, and 0.5. We can call it again with 1, 2, and 0.5. And, you know, hopefully we should also see the 6.5 from earlier. And we do see it. So this calc is overwriting the old one. We are completely redefining it. So as an exercise, let's see, copy this. So can you guys change your the calc function that we just defined here with these functions? Can we change it so that the result is now being divided by a new variable d before being returned? So here you'll be using the div function that we created earlier, this one here. And we'll want you to use the default value of 1 for d. So you're going to be adding a new variable called d with a default value of 1. And then you'll use it in the div function before returning the result. you'll want to return the result after it's been divided. All right, so this one's a little bit harder. Give you guys a little bit of time. Just raise your hand when you're finished. And if your hand is already raised and you're not finished, maybe unraise. So Luffy says he's confused. All right, so let's break it down a little bit. So we're going to be changing our calc function. We want to add a new parameter, default value. And in this case, we're going to be adding one with a name of D and with a default value of 1. And then what we're also going to do is we're going to change the return. So change, what is return? And we're going to change it by dividing the result by D. Does that make sense? Yeah, and then return it. You'll be doing it inside the calc function. So you'll be changing calc. All right, if anyone needs help, yell out. Give me a scream. I'm hearing some heavy sighs. So yeah, it's called a keyword parameter. Yes, so once you start putting keyword parameters, you can't put one that doesn't have a default value. You cannot put a regular parameter there. Exactly, yeah. So where am I supposed to put the D? That's a good question. Exactly. Yeah, I'll leave that one up to you. I'm just kidding. So yeah, so I was kind of just answering that question actually. So so D has to have a default value, right? And I just told, I don't even know who was asking the question. But I just told them that, yeah. Oh, that was you. Okay. Wait, you asked the question and then you, oh no, never mind. Okay, so when it has a default value, you can only place default values like at the end, right? So once you start putting parameters that have default values, like they all have to be default values from that point on. Yeah, Luffy's got it. So it doesn't matter where you put it in terms of M and E, but it definitely has to be after A and B, because A and B don't have default values. And the reason for this is pretty simple. So you can specify any of your keyword parameters when you're calling the function, you can specify them like wherever you want. But with the other ones, the only way to decide or the only way that you can know which one it is based on position. Yeah, they're called positional parameters, exactly, or positional arguments as well. And so when you're talking about positional parameters, like the position actually matters, but with keyword parameters, the name matters. So if you specify all of your parameters in order, it'll just use the order that's already there. But with keyword parameters, the order doesn't necessarily matter if you're specifying the name itself while you're giving it a value. So that's kind of why they're like intrinsically different. I hope I didn't confuse you more by giving you that long-winded explanation. Oh yeah, we'll be getting to a way to give an arbitrary number of parameters to a function. We'll be getting to that. Yeah, yours looks good, Garlic. I love your variable name, final. Final squared, indeed. All right, is anyone like on the right track, but they need a little bit more time? I was hoping to move on, but if there are people that are like still making progress, but they're just not quite done yet, I want to give you a little bit more time. I still hear a little bit of typing, so.
So functions have to start with def.
Sorry, what's that?
And do functions have to start with def?
When you're
Like,
defining a function, it absolutely has to start with def, yeah.
Okay.
That's the way to that's the way to let Python know that you're defining a function now.
Okay. And like right now we're just using it for math, so that's easier to understand, but you can incorporate other stuff.
Oh yeah, you can do whatever you want in a function. So the point of a
Okay.
function is that you can hold, it's just a place to hold some code that you can run whenever you want to run it. And then by passing the parameters, you can change the output a little bit, right?
Oh, so if you add loops, you can add it after, and defining the function means that you don't have to define things outside of the entire system. So you put it all inside def and start with the things that you're going to use in the loop inside def when you're defining it.
Yeah.
Okay. I was a bit confused at the start, but it makes sense.
Gotcha. Awesome. Yeah, hopefully we'll get to async and await some other lesson. Definitely out of the scope here. All right, where are we at? Okay, so I will give you the answer now. So we're going to change calc. So I'll just start with calc. I'll start with the declaration at least. So we'll want to return a value, and it's going to be a plus b. And then we're going to multiply the result of that by m. Right? And then we're going to add e to it. Right? And then now we're going to divide by, we want to change it to where we have an optional parameter d, and then we want to divide by it. So we'll add that in. So we'll say d equals, and then a default value of 1. And then we want to divide by it. So we call div by d. So yeah, obviously this is completely unreadable, right? But it works. And just kind of illustrating that point, right? So you can make your code as unreadable as you want to, but like know that you are potentially hurting someone. Yeah, Inception Code. Well, it'll get even more Inception if we do recursion. Absolutely not. Nope. It's the exact same except for that. If we made a new function. Yeah. Yeah. Absolutely. So this here that I've highlighted is essentially the old functionality of Calc. So if we replace this with Calc and we just pass A, B, M, and E, and then we call this one new Calc, this is perfectly acceptable. It does the exact same thing, right? Because we're taking the old Calc function and we're just dividing the result by a new variable D. Yeah, absolutely, this works. How about another way of doing this? Actually, no. This is probably fine. Yeah. So importing is basically when you've defined things in a different file and you want to import them into this file. So like we have there's this section on the side called files, and then we're always in main.py. So we can add additional files and we can define functions there and we can import them here, right? So that would be exactly the same thing. So right. So oh no. So add and div and multiply, like we've defined them in this file is what I mean. Yeah. And so oh yeah. So they're available here, right? We could define them in a different file and then we would have to import them. And then, you know, you were talking about importing like the math library. So the math library has other things like pow. So pow is like power. So you could take 9 to the 10th power or something like that. And we would have to import that function, definitely. Oh, no problem. The struggles. Reminds me of when I was working on C++ code originally, and then I didn't know how to run it on the command line because I was always using the editor. The editor did everything for me. Okay. Let's see. Can you define a new function inside of a function? So I like that one. And the answer is yes, absolutely. So functions are just variables, basically. So when we're saying def new calc, this is like the standard for defining a function. But really what it's doing is it's creating a variable called new calc, and it's assigning a function to it. So functions are just like values, just like we've used A and B are values, and D is a value, 1 is a value. And so you can like assign functions to other variables if you need to. If we just say like x equals calc without the parentheses, this is a function, and we're assigning this function onto this other variable. So this is a perfectly valid situation. And you can pass functions around and you can call them, and it can get really confusing. So we're not going to jump too far into that at all. But yeah, currently this is just making an alias. But imagine if we had a different function which accepted a function as a parameter. Then it's not exactly an alias, but more like that function does stuff, and we can customize what it does by giving our own function as input. So as you can see, it gets pretty confusing, right? So a little beginner unfriendly, definitely. But I digress. We will move on. A little bit of taste of what's to come. All right, so somebody was asking earlier about creating functions that accept an arbitrary number of arguments, and we can do that. There's something called the star, as one of my teachers called it, the magic star, because it lets you do magical things. So let's see. Wait, where is this in the lesson thing? It like disappeared. Oh, it's like way down here. Wait a second. Oh, all right. This is weird. Okay, I guess we'll leave this for later. No, there's like a comment up here, Exa, and it says something that comes later. So I'm just gonna like remove that, I guess. Because that's down at the bottom. Okay. So you can pass anything to a function, right? So we'll talk about passing a dictionary to a function. So we'll say make description. We'll pass a Pokemon into this function. So our Pokemon dictionary, our Pokemon is just a dictionary here, is what we're expecting. And so if we want to take a dictionary and we want to turn it into a string that we can kind of just print out, that's like a useful string, we can write a function to do that for us. So let's say we have a Pokemon that has like a name and a level. We can create a function that takes that name and that level, turns it into a string, and returns it for us so that we can print it out if we need to. So let's just start with that. So we'll say name equals Pokemon name. Say level equals Pokemon level. You can say message level So this function extracts the name and the level of the Pokemon from the dictionary that's passed. And then it creates a message, Pokemon name is level, and then just returns that message. So this is essentially a function that converts a dictionary into a string, given, that this is how we do it. Okay. So let's make another function that just takes a Pokemon dictionary and it just goes ahead and prints out the description directly. So we can say print description. So first, it'll create the description by using make description. And then it's going to print it out. And as you can see, this function doesn't actually return anything. So every function that we've made so far has a return. This one does not. So what does this function return? It actually returns the none value, which I talked a little bit about earlier. So none is a special value, and you can compare with it by using is. So we can say x equals print description, and then we'll actually have to make a Pokemon before we can do that. So we'll give it a name. And we'll give it a level. Oh, Jesus. We're going to make it level 94. We'll give it some health too. So now if we say we want to print the description of this Pokemon, we can do that just like this. And we are expecting that X is none here. And the reason is because this doesn't return anything. So this should be a valid case. Yep, and we see none. So the none isn't actually important, and we don't need it at all.
Question.
Hmm?
Is none like null?
None is very much like null.
Okay.
So yeah, so because any variable can have any type, it's not necessarily the same thing as null. As in, like, a variable that would hold an int can also hold none, and that's like a valid case. But in other languages where null is used, typically it's to represent like a pointer that points to nothing. So not exactly the same thing, but there are similarities.
Okay, thank you.
So none, its name is none, and really all it stands for is there is no value. So using none with any context other than there is no value doesn't exactly make sense.
And say, like, right there where you get a none value out of a function, you can use that, like, you can use none as something to compare to, right?
Yeah, so if we saved X from print description and we said print X is none. So in this case, you have to use is because none is like a special type. There's only one none in existence. And so when we say is, we're comparing to that original none object. So this is, like, literally, it's the same thing as this none.
Kind of like an equals, but not really.
Yeah, it's not exactly the same thing as equals, but there is some sort of equality check going on.
Gotcha. And that should return like true, right?
And this should absolutely return true.
Got it.
And this comparison to none is useful in a lot of places because a lot of times libraries will return none in certain situations. Like if there's, I don't know, as an arbitrary example, like if you're using a function that returns values from a list and then there's no more values in the list, then the next thing it'll return is none. And once it's none, then you know that there's no more data to be processed. So it can be useful, but it's not always useful. Okay, let's see. So yeah, also I kind of passed over it, but our message got printed to the console here. So what happened here? So we have this print description function, and it took our Pokemon as an argument. It calls our other function, make description, with that same Pokemon, and it gets a message from it. So that message is what we constructed from this function. And then we just go ahead and print it directly. We don't return it, we just print it. And that's how it ends up here. So is string of level needed? So this here. And the answer is yes, because level is an integer. It's not actually a string. And so when you're trying to add, because this is a string, this is a string, and this is a string. And when you try and add an integer to a string, it's not going to let you. And so what you have to do is convert it to a string first. All right. And so this is the end of part 1. If you guys want, you can do an exercise and kind of write a function for whatever you want. Or you can just take a break. Breaks are cool too.
Yeah, let's just take a break.
Yeah, so this is the end of part 1. Part 2 is going to go over more in-depth function stuff. And then there's going to be an activity at the end, a fun activity. But hopefully we don't run out of time for that. Mutability and pass by star.
I think it's like spot on.
Yeah.
Right?
So yeah, we'll be talking about like mutability of things that are outside of the function, but still within scope of the function. We'll be talking about that. Not pass by reference and pass by value. There is no pass by value in Python. Everything is pass by reference. Okay, so I guess that's not entirely true. But pass by reference and pass by value is like a concept from other languages. It's not really something we're going to like get into. We'll talk a little bit about the difference between like certain types passing when you pass it to a function and how it'll still modify even outside of the function. But yeah, so not basic types, but any like construct types definitely pass. They're all passed by reference. Making a deep copy is a little bit harder than it would be in other languages potentially. So we will be passing by star, but it does not mean the same thing. So yeah, but Axel will get into that.
I'll get into that. Aren't like large integers also passed by reference?
Yeah, I mean, anything that's a class is passed by reference.
Everything is a class.
Yeah.
So everything is passed by reference.
Basic types are not classes. So like integer, string.
Yeah, but that's what I asked. Isn't like large integers also passed by reference?
Yeah. Large integer though is a class. It's not a basic type, and that's why it is passed by reference.
Are strings immutable?
They are, yeah. They are immutable.
Is there a string helper library for string?
Strings themselves have methods that you can use directly. So if we have a string, you can hit.
You're gonna do like a lot of string operations. So
Mute on Discord probably.
well, I am. But basically, if you're gonna do a lot of string editing,
I forget. Yeah, there's totally something that you can use, but I can't remember. Do you remember Exa? Was there like a, let's see.
What do you mean by string builder? I don't really understand the question.
So it's basically something that uses like a buffer for building a string so that it's like efficient and not like
No,
string concatenation.
I've done like excessive work with like strings, and to my like best knowledge, there's nothing like a string buffer that you can use. Maybe there's a library out there for simulating string buffering, but chances are that all they're doing is using a list in one way or the other or another. So no, to answer like in terms of efficiency, chances are you're not going to find anything more efficient than simply using a list with single character strings. And you can just pop in and out.
Yeah, so I mean, basically what this is saying is like the underlying implementation of string concatenation has been optimized in a way that is actually pretty efficient. So, I mean, obviously it's not going to be as necessarily as fast as using something that's built purposely to be like a string buffer, but you can totally just concatenate strings together and the implementation is pretty good.
The best string buffer you can use is a string.
Exactly. Yeah, we'll be getting to args and k-args.
All right, should we get going with part 2?
Yeah.
All right.
And
I
how
think
do
you
I...
need to stop sharing your screen so I can share mine.
There we go.
All right. Just give me a second. Oh. Cool. Share screen. Where's the thing? There's the thing. That's my thing. Just give me a second. Yeah, I'm sorry, I can't work with light themes. They just burn my eyes because my eyes are just sensitive like that. Okay, so part 2, we're gonna get into a little bit more in-depth stuff. What I think TB should do is just post the code that he has in the session voice text channel, because it's not going to be available on my screen. TB, you got that?
Yeah.
All right, cool.
It said my plugin crashed. Okay, I still have everything.
Okay.
I was worried.
Okay, what I need to though is the Pokemon that we made, just because we're going to be using that a little bit more. So this is our Pokemon. It's a Magikarp. Let me. Ooh, that's big. So yeah, we have this Magikarp Pokemon, which is just a dictionary with stuff, and we also had our sort of show description function that gave us a sort of easier representation of our Pokemon without having to see the clutter that comes with just printing out the dictionary. But what we're going to talk about now is mutability of container types. It's okay. Mutability of container types. So let's make a function that levels up our Pokemon, right? So let's call it level up. And for this kind of thing, I would suggest that you guys sort of follow along, like sort of type the same things, just because it really helps when you get to experience what's actually happening rather than see me do it only. So what a lot of you, I'm assuming, would expect this function to do is accept a Pokemon, change its level, and then return a new Pokemon with a new level. However, it's not quite what's going to happen. So what we're going to do is we're going to increment the level by using the shorthand increment operator that I think we talked about on workshop 1 or 2. And that's it. That's all our function is going to do. We're not going to return anything. And let's see if it actually works. And we're going to see, I'm going to make Pokey just because Pokemon is too long. And let's see if it actually works. So let's bring a Pokemon before. Let's level it up. Let's bring a Pokemon after. See what happens. So we see that it got from 94 to 95. What I assume some of you might be finding odd at this point is why, like, we're printing the same variable before and after calling the function, but it's actually changed, which should sort of hint at what's going on here. So our Pokemon is just a dictionary. The fact that we mutate or change the dictionary within a function doesn't mean that we have a new dictionary. There's still a single piece of data that's being referenced by this variable and by this variable, inside and outside a function. It's the same dictionary. So when we change the dictionary in the function, it also changes outside of the function. What happens in the function stays in the function, but the difference here is that this, like the underlying data of this variable, also exists outside of the function. And that's why not only can we access and pass it in the function, but we can also access it outside afterward because we already had it outside. I know this can be super duper confusing. So if someone like is a little bit unsure about what happened here, please just chime in and let me know, because I'm going to be going into more advanced things surrounding this concept. And unless you get it, you're gonna have a hard time, unfortunately. Is everyone sort of okay with it, or is someone like completely, absolutely lost as to what happened here? Okay, that's amazing. It's amazing. So let's talk a little bit about something that in programming you'll find by the name of scopes. I'm actually trying to talk about this with using the word scopes as little as possible, just to indicate that you don't need to be super duper technical about it. But what I'm going to do is I'm just going to use this as a separator for the next section. So let's make a function, right? Let's make the infamous calc function, but let's make it a little bit simpler, right? Let's have it only take 2 variables or parameters or arguments, whatever you want to call it, A and B, and let's have it return the addition result of them. But let's have a twist. What we could do is we could have a default sort of value for m, and we could just multiply this addition by m. We defined m and e before when TB sort of talked about this whole thing as a default parameter, as a keyword argument in the function. However, what I'm going to do is I'm going to define it outside of the function. Okay? And now you'll be asking, but if it's outside of the function, why are you using it inside of it? Well, the answer to that is everything inside the function also has access to everything outside of it. But everything outside the function doesn't have access to everything inside the function, just because everything that's inside the function is variable to change. It's subject to change according to what we call the function width. So let's just sort of showcase our function. Let's call it calc, let's say 1 and 2. Let's print this result. And if my math is right, we'll get 3. And what I'm going to do now is I'm going to change the m outside the function to 2. And I'm going to simply do the exact same thing and see what we get. And we got 6. So without changing anything in regards to how I call the function, without changing the implementation of the function, I got a different result just because I changed the variable that the function is using without actually having ownership to it. It's not local to the function. So this is, if I were to get a little bit technical about it, we said that m is part of the outer scope of the function and not the inner scope, but the function still has access to it. Yes, variables outside of functions can be seen inside of the functions, but variables inside of the functions can't be seen outside, which makes sense because if I made this function here and then I tried to print a, this a has no value. At no point am I actually assigning a value to a. The only instance where I'm assigning a value is when I call the function, at which point I go in the function, I go in the scope of the function. So TLDR, functions have access to outside variables, but outside variables don't have access to function variables. So you can sort of play with this for a little bit. You can even add like an E variable and use the E variable in the same way that we did before and play around in that way. But that's that when it comes to scopes. Yes, I think Devath's analogy is actually a pretty good one. Is everyone like okay with this? I know it can be confusing when you first encounter something like this. Okay, winter's good. Is everyone else good? Okay. Okay, that's really surprising. Good job. All right. Let's see. Okay, so we got an exercise coming up. So the exercise is make a function. Okay, I'll just type it out, okay? Make a function that takes user input and adds it to a list that lives outside of said function. And I'll help you out a little bit by going ahead and just creating the list. So this is our list. We'll call it just L. Let's just name it L. And here I want to make a function that takes user input and adds it to this L. Just a reminder, user input is fetched using the input built-in function. And you can do it like I equals input. And then once the program gets to here, it will ask for user input in the console, and then whatever the user inputs will be passed into I. So, and what I'm asking is to make a function that puts this I in this L, and then call your function 2 or 3 times, just so you populate the list a little bit, and then we'll print out the list to see if it actually has all the stuff in it.
Or you can use a loop like last time.
Or you could use a loop, exactly. So I'll give you guys like 3-4 minutes maybe. So a lot of you guys have your hand up from past exercises. Just lower it so I can actually tell who's done with the exercise. And raise your hand once you're done with the exercise. Thank you. Hell yeah, of course. Be creative. It doesn't need to be as simplistic and arbitrary as they make it. Okay, winter's done. Remember, the list has to be outside of the function, like our M variable. If someone's stuck with something specific, you're more than free to just chime in and ask or anything.
So we don't need to use the calc part.
No. That's completely outside of whatever calc is supposed to do. This is more so to illustrate scoping rather than addition and multiplication and using functions and functions. This is a bit difficult. I see only Winter has finished so far, so I'll give you guys a little bit more time. As a hint, you can sort of go back to our modified calc function and see how it uses M inside the body of the function, even though it actually lives outside of it. Okay, flux is done. If you're completely stuck, feel free to ask or anything. Winter, as a challenge to yourself, try to make this as simple as bare bones as possible. The function to add to a list is l.append. Okay, Dario, you're kind of lost. How, where are you lost? Where are you stuck? Input command, okay. So you do I equals input, exactly like this, right? And when you run the program and the program flow reaches this function, a little prompt is going to come up in the console. It doesn't show anything. In fact, you could do something like this to indicate that you're supposed to input something. And then you type in the console, press enter, and whatever you typed will be passed into this I variable. So input is the function. It has an optional argument that you can pass. And the result of the function goes into this I, which is whatever the user typed and pressed enter. Take your time. Okay, Maestro is done. Hamstripe is done. Gallic block, cool. Let's spend another two minutes for this. Winter, like I said, as a challenge to yourself, try to dumb your solution down to be as bare bones as you possibly can. If you think you've taken unnecessary steps to sort of solve this, then try to figure out what those unnecessary steps are and eliminate them. Okay, GLaDOS is also done. It's been a minute or so. Devath, nice. It's actually pretty amazing. You guys are getting it. You don't need anything in the brackets when defining the function. Yes, this function doesn't really need anything as parameters. Okay, that's okay, Winter. Okay, how about I show you guys how you would go about doing this in the simplest way possible. And Winter, you can see how much your solution aligns with mine. And yeah, you can always just send stuff to TB and he'll tell you how good or bad your solution is. So what we want to do, is again make a function that takes user input. So let's just focus on that first. So let's just name our function new or whatever. Give it a name. Doesn't particularly matter. In my description of the exercise, I'm not asking for any arguments. So our new function is actually not taking any arguments at all. So what happens in this function is we get user input like I described, like this. And then all we do is put the user input in the list. And that's all. That's the most bare bones approach that we could go about making this function. So what I'm going to do is I'm going to run this function a few times and allow me to populate the list. And once I'm done, I want to print the list. In fact, what I'm going to do is I'm going to be printing the list after each time that I run the function. Okay. Okay, I can do with a loop after this. Just to illustrate how you could go about doing this with a loop. So I'm going to have something in my list. I'm going to have anything in my list. I'm going to have nothing. And this is my final list. So a function that takes user input and adds it to our outside list. So see how I call the function with no parameters whatsoever, and right after calling the function, without passing the list as an argument, I referenced it and I printed it. Okay, and before I ask you guys how close you were, I'm gonna show how you can do this with a loop. So you can do for, or you can have an index. Let's just have an index. With an index equal to 0, while index is less than 3, new index plus equals 1. So this is how you would do it with a loop, with a while loop. Again, my list has something, anything, and nothing. I'm not printing the list, so we're not going to see it, which is anyway. So having all that said, how close were you guys to making this? This, by the way, this is all that you had to do to solve the exercise. The rest are just quality of life things for calling it multiple times. Just give me a number from 0 to 10 in chat as to how close you were. Okay. Cool. That's amazing. Turkis, that's okay. That's okay. It's whether your function needs an argument or not is contextual. It has to do with what you want your function to do. In this case, we don't need to pass something to our function. Okay, you didn't know the append thing. That's okay. Just if you plan on attending more tutorials, which I really suggest that you do because we're going to get into some really cool stuff very, very soon, I would strongly recommend that you watch the VODs for the previous tutorials especially the last one, which goes into while loops and dictionaries and so on and so forth, and the one before that, where we learned the append function. Okay, cool. I'm going to go a little bit further, like a step further, and I'm gonna sort of stick. Sorry if I pause my like screen share for a split second now and then. I'm moving like the screen around. So I'm gonna take this a step further and sort of get a little bit creative, like someone did. I don't remember who. I'm so sorry. And I'm gonna sort of keep in like stay with the spirit of the whole like Pokemon thing. So what I'm going to do is I'm going to have a list of Pokemon, and I'm going to be populating it with Pokemon. So new Poke, and gonna say Poke is from input, and keys to append Poke. And another way you can do something a certain amount of times is you can do for something in range and then the amount of times you want to do it, instead of using a while loop. We haven't learned the range function yet, but it basically returns a list of numbers from 0 to whatever you put here. So 0, 1, and 2, excluding this. So let me try this. What are some Pokemon? Let's do Celebi. I like Celebi, I'm sorry. I don't know why I keep using it. Well, I haven't, okay. Let me also print the Pokies after, before I do anything. So Celebi, let's do Pikachu, and let's do Magikarp. There you go. It's my list of Pokemon. And you know what? I'm gonna go a step further. Data lessons you could help highlight surprising well. Okay, I'm going to take a step further and sort of modify my function to change this input according to a parameter. And my parameter will be whether the Pokemon that I'm trying to create is a shiny one. I'm going to have it false by default. We used numbers before as the default values of our parameters, but you can use anything. You can use strings, booleans, integers, floats, anything. In this case, I'm just using a boolean, which is false. And after I get my Pokemon, I say, okay, if I'm trying to sort of define a shiny Pokemon, what I'm going to do is I'm just gonna prepend the word shiny in my Pokemon's name, Poke. And then it's just gonna continue down here. And for this purpose, after doing this 2 times, I'm gonna do it 1 more time. Shiny is true. Let's see what I get now. Again, I'm gonna do the same things just because I don't know that many Pokemon. And something else. I don't want to do Magikarp. Give me a Pokemon, anyone. Just type a Pokemon in chat. Okay, thank you. Charmander. So I got a Celebi, a Pikachu, and a shiny Charmander. I didn't pass the shiny word here, but I just specify that now I'm just trying to define a shiny Pokemon. So I was able to alter the result of my function in accordance to the new sort of default variable that we had. So does everyone understand what's happening here? Is everyone A-okay? A-okay? Come on, if statements are easy. No. Python doesn't do curly braces. You can do, yeah, you can do parentheses here, but other than that, curly braces aren't really a thing with Python. Well, yes. Well, in Python, for the most part, parentheses have the same meaning that they have in math. So if you do 4 plus 5, or you do parentheses 4 plus 5, it's still the same thing.
So you don't need it unless you actually want to cut it.
Exactly. The underscore is just like a placeholder sort of name for a variable that I get from this for loop. It doesn't actually have a semantic meaning. I could actually have anything here. I could have this, and it wouldn't matter. The underscore is just like the most small and minuscule name of a variable that you can come up with. That's all. And because I don't need it, I just try to make it as small as possible. But I could have this, and it would still work.
So I made a method function that gives you all the Pokemon.
Okay.
If I want to leave the function early, like I haven't checked the Pokemon, can I just return them?
Yes. Yes, you can. You can just type the word return without anything next to it, and it just terminates the function execution and returns nothing. It returns none. Yes. All right. So since everyone is A-okay with this, let's go into sort of another thing that some of you guys mentioned. What I'm going to do, though, is I'm going to comment this out just because every time I run the program, it doesn't ask me for input. So functions take variables or arguments or parameters. I use those words interchangeably. TP will tell you that they're not exactly the same, and he's right. I'm just a rebel, that's all. So they take parameters of any kind, but they can also be modified or defined, rather, to take parameters of any amount. So how you do this, let's make our add function. Before we took A and B, but let's make it so that it can take as many numbers and add them together, okay? How you do this is with the asterisk. So in other languages, this is related to pointers or references. Python doesn't really have the mechanism to fiddle with those things. So the asterisk is reserved for another purpose, which is this. So this is variable length, variable amount of parameters. And how you do this, you put the asterisk and then the name of the variable that you want to store everything that you're going to be passing. I know this sounds weird, and I'm probably explaining it in an overcomplicated way. So let me just print right before I do anything. In the function, I'm just going to print this variable. I'm going to call it with 1, in which case we should get a tuple or a list with just 1, 3, 4, 5, 6, 7, 8, and so on and so forth. In which case, inside the list, we would get all these things. Inside the function, sorry. So what I want to do here is to add all these numbers together. And you can easily do this with a for loop. So you can start with a result, that's 0. So we start with nothing. And I can say for number in numbers, nums, result plus equals num. And then I'll just return the result. And in this case, I can just print the result of this function, and it's going to give me whatever the addition or summation result of all those numbers is. I can just get rid of 5 of them, and the function is still going to work. It's a variable amount of parameters that's being accepted. But all of these are positional only parameters. So right now, we don't know how to do keyword ones, but I'm going to show you how to do that right after. Is anyone stuck? Anyone wondering what's going on? Anything I could be explaining better? Is everyone A-okay with this? So this really just allows you more flexibility in terms of just defining your functions and allowing them to do like non-specific things necessarily. Okay, well, that's that's a for loop. We talked about this in the last workshop, but basically for number in numbers. So this is a loop that iterates over each element of the numbers list. It's a tuple here, but let's just go into list for now. So it iterates over each element of this list and it assigns it to this variable. And then I'm using this variable to keep adding on to the result. Did this short description of what's going on make sense? Okay. Anyone else lost, or please just chime in and interrupt me or whatever if you're lost. Because if you don't get this, you won't be able to like follow along on like the super duper fun, creative, extra amazing thing we're gonna be doing at the end. Didn't get the nums. Well, that's the point of the whole thing. So there you go. So the nums is the asterisk. So if we didn't have the asterisk, nums would be one variable. So we wouldn't be able to pass multiple variables here. We would only be able to pass one variable at a time, right? What the asterisk allows us to do is to pass any amount of variables, any amount of parameters or arguments. And instead of being those arguments themselves, it's in list containing them. That's all. Okay, all right, cool, sweet. So in the same way that we can do this with positional parameters, yes, in the same way we can do this with positional parameters, we can also do it with keyword parameters. So let's make a function called backpack, just because I couldn't come up with a better example. Our backpack takes an arbitrary amount of keyword arguments, and how we define this is with 2 asterisks. It only goes up to 2, I promise. It doesn't go up to 3 or 4. Our variable here is stuff, or our parameter, and what this stuff will be is a dictionary. Let me just print it before I actually make the implementation of the function and call it with something. So A equals 4, B equals true, C equals hi there, and let's just call it and see what happens. Backpack. Okay, so this is what we got from inside of the function. It just makes a dictionary. Yes, Winter. This makes a dictionary. So A is 4, B is true, and then we get another key C, which is hi there. Again, any type, any amount of parameters. I could remove 2 of them, and then I would get a dictionary with just A inside of it. Okay, having that said, what I'm going to do is for key, yes, that's the whole point, is flexibility. For key in stuff.keys, for those who didn't participate in the last workshop, stuff.keys basically returns a list of all the keys in the dictionary. In this case, it would return name, it would return A, B, C, or whatever I had here. So if I do this, it's going to give me A, C, and D, which will be strings. And what I'm going to do is amount equals stuff key, print you have plus amount of could just do this key. Okay, so you can use them for strings as well. You can use the 1 asterisk for anything. It doesn't need to be strings. But any type. In absolutely no case does Python itself limit you in regards to what kind of arguments you can pass into a function. The implementation of the function itself might have like weird consequences if you pass types that you're not supposed to, but Python itself doesn't care. So let's call our backpack with those arbitrary parameters. Okay, I need to add like a space here. And now that we've tested it, let's say that in our backpack we have master balls. Let's say we have 5. Let's say we have rare candy. Let's say those we have 2. And let's say we have repels. Let's say we have none of those just because we hate wild Pokemon. So we have 5 master balls, we have 2 rare candy, and we have 9 repels. So does anyone follow what's going on here? I'm iterating over the keys of this dictionary. I'm fetching their respective value, which I sort of put in place to be the amount. And then I just print the amount against the key. A's key and B's value. Well, you're calling backpack with positional parameters. Backpack doesn't get any positional parameters. It only gets keyword parameters, which is denoted by those 2 asterisks. Add takes positional parameters and no keyword ones. Does that make sense, Block? Okay. Well, to further push this point, and maybe you'll get it with this, you can make functions that take both an arbitrary amount of positional and keyword arguments. So you can have some function, right? It takes any amount of keyword arguments, sorry, any amount of positional arguments and any amount of keyword arguments. And these 2 words are actually sort of a convention amongst Python developers for signifying, for sort of naming arbitrary amounts of positional or keyword arguments. So just make a function literally like this and print the arguments and keyword arguments. And how you can use this function is in any way you want. So you can pass anything here as a keyword argument. You can pass none. You can pass strings. You can pass keyword arguments. And so on and so forth. And over here, we get all our positional and all our keyword arguments. So is there anyone who's sort of on the fence about whether they understand variable amount parameters? Okay. Yeah, I figured just showing you that you can just use both would make understanding it a little bit easier. You kind of do. That's okay if you kind of do, honestly. Because while you developed, when you encounter this, you're gonna be like, oh shit, I've seen this before, and I kind of know how it works. It means it's variable length. It means that I can pass however many I want. So let me just pass like 11 of them, 12, 3, and see what happens. What do you mean manage the parameters, Winter? Krimineko, yes, sort of. Practice makes perfect. If you're curious, you will use it more. Winter, what do you mean by managing the parameters? Yep.
When I need.
Sorry? And when well, Winter, when you define a function that can take an arbitrary of parameters, your function should also be able to handle an arbitrary amount of parameters. like we did with our addition function. Here I'm allowing the user to pass an arbitrary amount of arguments, but I've also created my function in a way that can handle that. In my backpack function, I allow the user to pass an arbitrary amount of keyword arguments, but I also sort of use the full extent of those arguments. You can use things like tag checkings and things like that in the function itself, but that's up to you. That's up to how you want to implement those things. Key is the label of a variable in a dictionary. Value is what the variable actually is. Yes, sort of. No. Look, you don't pass the string of X. You pass X. Yeah. Darkest, I would really suggest that you watch the VOD for the last workshop, because we really go into dictionaries there, and we sort of do some really cool stuff where we actually fetch a whole bunch of like dictionary data from an online Pokemon database, and we go through that. It's really cool. So if you're curious about that, definitely check it out. They are in the resource channel, coding resources. They should be there, all of them. Everything should be in coding resources, from previous VODs to code to everything. Yeah, sometimes I forget the names too, that's okay. Okay, so this is give or take the full extent of what functions can do. So having all that said, and having shown you guys all this, let's go and be a little bit creative, okay? Creative time. We're not learning anything different now. We're just using everything that we've learned, okay? So in the last workshop, we got to create our own Pokemon. And how we did this, instead of just representing them with names, we represented them with stats. So there were dictionaries. Our Pokemon had names. Give me a Pokemon name. What Pokemon are we making? Anything. Okay, I'm just gonna go with the first one. First come, first serve. Yeah, TB, you can go. It's fine. Thanks for participating and stuff. And good job on the first part. Take care. Hell yeah. All right, so thank you. We're gonna have fun with this one, I promise. This is gonna be really fun. So another thing like Pokemon usually have in the game is an attack. So in this case, the attack will be a multiplier, right? And I'm going to explain how this works a little bit once we get to the Pokemon moves, right? But for now, the multiplier is from 0 to something, to 2. So how strong is actual? Let's say that it's, what is actual? I don't know. Anyway, let's just say that it's not that strong. So it has an attack multiplier of like 0.78, okay? Now, what's its defense? You know, I'm gonna let you guys like tell me the stats. What's its defense? Another multiplier. The higher the defense, no, the lower the defense actually, the better. Because the defense is by how much it's going to be reducing damage. 0.4 is really strong. Just pick a lower, higher number, sorry. Because it reduces all incoming damage by 0.4. Okay, 0.8. Winter, I wish it could just be faster, but I digress. Our Pokemon also has a health. How much health does this Pokemon have? Just pick something between 100 and 200. You can go 300 if you want. 120, all right. And it has moves. Every Pokemon has moves, right? Let's give it 2 moves. So moves is a list of dictionaries. It looks a little bit weird, I know, but it's just a list of other dictionaries, and each dictionary represents a move in the same way that we sort of represent Pokemon. So each move has a name. What's the name of the first move of this Pokemon? Dragon Tail. And how much power or damage is it supposed to do? So this value is going to be multiplied by the attacker's attack and the enemy's defense. 100. That's really strong. That would kill a Pokemon with the same health of this one in 2 shots. Let's come up with something between like 20 and 35 or something. 32. There we go. And I think that's pretty much all we need to define a move. Just the name and the power. Obviously, there's more to a move. There's like the type and what status effects it brings and conditions with weather and how many turns it takes. But for now, for our simplified sort of representation, let's just keep it at that. Give me another move though. Another move, a second move. Anything. Tail whip, okay. And how powerful is that? Let's make this like a little bit more powerful than the last one. Just a little bit. 42. All right. So this is our Pokemon. And what I want you guys to do is make another Pokemon so we can have them fight. Do that on your end. I'm gonna do it on my end and name it Pokemon 2. So Poke 2. So this is my Pokemon. I'm gonna make this one. So mine is a Milotic, just because I think that's a really fucking aesthetic name. It's a little bit stronger. Actually, no, it's a little bit weaker in terms of attack. So has 65, but it's a little bit stronger in defense, just so it can balance things out. So it has a 91 defense. It's on the same health. It has a little bit more health, just a little bit, by 16. Yes, it has lower defense, but I'm actually using a higher number to indicate, oh, lower defense. Oh shit, you're right, sorry. Whoops. Thank you. Let's say 74. So what moves have I come up with this one? Okay, it has tackle. Tackle. Let's say this one it's less strong, so let's give it 36. Actually, no, tackle is pretty weak. I'm gonna give it 23. And then it has wrap, which is actually pretty strong. Let's have it too. Well, I don't know if it's strong in the games, but it's strong here. Let's give it like 53. Don't want to use 3 again. 51. Stick with 51. And I have my 2 Pokemon. Let me know when you guys have your Pokemon. Use the raise hand features just so I know whether you have your Pokemon. So we can get them to like fight each other and stuff. Okay, Bloke has his Pokemon, GLaDOS has their Pokemon. Gallic, Hamstripe, Fluffy. You copied mine. The point of this thing is to be creative. Don't copy. What's the point? What's the point? This is called creative time. Fluffy, Flux. Me neither. Bloke, me neither. But I try. Okay, you were creative, but you came up with my Milotic. All right, freaking copycats. Screaming Echo. Winter, cool. Let's wait a little bit more. Come on, I want everybody to have a Pokemon. 1 more minute. I'm gonna give you guys 1 more minute. If you're struggling with sort of like the syntax of dictionaries, you can just copy paste the first Pokemon that you made. if that part slows you down. So while Roy, I'm just gonna call you Roy. So Roy's done. Have their Pokemon. Okay, cool. So all of you guys have your Pokemon. So let's make a function that when a Pokemon attacks another Pokemon, it just calculates the damage that it's supposed to do. Big sniff and rap battle. Yeah, exactly. So you can be creative. Last workshop I taught, when we did dictionaries, so we made Pokemon like this, every Pokemon actually had a nickname, and everyone just decided for our Pokemon to be called Kanye West. So you can be creative in any way. But let's make a function called calc damage. Okay, this function takes one Pokemon, it takes another Pokemon, and it takes a move, the move that has been used. So in this case, what I do is how this function is meant to be used is Pokemon 1 is the attacker, Pokemon 2 is the defender, and the move is the move that the first Pokemon has actually used against Pokemon 2. You don't need to pass the variables in this order. You can pass them in this order. You can define the variables in any order you want, as long as you also change the order that you pass the variables afterward. So the formula that I came up with before the workshop as to how you could be calculating damage is you could take the move's power, so the power of the move, times the attacker's attack times the defender's defense. Okay? So this is our base value. It gets increased according to how powerful the Pokemon that we use is. And it also gets decreased. Well, that's why we always chose. It gets multiplied. I shouldn't say increased. It gets changed up according to how bulky the enemy is. So because we multiply for defense, that means that higher numbers actually lower the damage less than smaller numbers. That's why Axial is actually less sort of beefy than Milotic, because it has a higher defense. So it lowers the damage like more. I know it can be a little bit confusing, but just bear with me for this example. Okay, now we have the function that calculates the damage. Let's make a function that just makes the two Pokemon attack each other. So to do this, we're actually going to use a little bit of randomness, just so we can make things interesting and not having the same result every time. So what I'm going to do is from random, which is a built-in library, I'm going to import choice and sample. And let me just give you guys some brief descriptions that I have ready of what these functions are supposed to do. So random is a library, choice and sample are functions. And here I sort of type out what they're supposed to be doing. You don't need to think too much about this line. Just know that once you do this, we have access to these two functions that just help us introduce a little bit of randomness. If anyone at any point is stuck or unsure about what's going on, just interrupt me. I will not hate you. I promise. So having that said, and before I do anything else, what I'm going to do is I'm just going to round this, right? Because afterward, we're going to end up with like 0.11 numbers after the decimal point. So I'm just going to round this to a single integer, just so we don't have a huge clutter of numbers. And having all these things, I'm going to define an attack. So this whole thing might seem a little bit dragged out, but you can think of it as building a project, right? It has components and steps that we're trying to take. So that this function will take the two Pokemon that are attacking each other, and what it's going to do, it's going to pick a move, a random move from the first Pokemon, So Pokemon 1 moves is the list of moves that the first Pokemon has, and it's a list, and passing the list to this choice function returns me a single random element of that list, so a single move. Okay? And then what I do is I just calculate the damage using my calc damage function. My attacker is Pokemon 1, my defender is Pokemon 2, and the move that I'm using to attack Pokemon 2 from Pokemon 1 is move. What's up? Someone said, hey, what's up? Okay. So we've calculated the damage here that Pokemon 1 is going to inflict to Pokemon 2. And you know what? At this point, let's just print it to show what happened, okay? So Pokemon 1 name used and the name of the move name. For yeah, maybe they're not in Zoom. Okay, for damage. Okay, so here I just show like which Pokemon used which move and how much damage they dealt. All right, so what I'm going to do now is I'm just going to deduct this damage from the enemies. Or, oops, saving. I'm just going to deduct this damage from the enemy's health. So I'm just going to fetch the enemy's health here. Okay. And I'm going to do health minus equals damage. I'm actually going to write the full name of the damage since I'm writing the full name of the health. Okay. So you can keep using DMG if you want to just change my DMG to syrup damage. Okay. I'm missing my plus. Thank you. Thank you so much. So I'm just deducting the damage from the health, and I'm just assigning it back. So instead of doing this whole thing, what I could have done is poke it to health minus equals damage. But I'm actually going to be using this health variable more further down the line, which is why I need to fetch it here. If I didn't have any more use for this Pokemon's health, I would be doing this directly. But since I'm going to be using this health variable again, which is what variables are used, they exist for, is to be used over and over. If I didn't need to do that, I would just do this. But since I'm going to use it again for printing the health, I'm gonna assign the health as a variable, then I'm gonna pass that variable back to the dictionary. Does sort of everyone understand what's going on here? It's the same concept as when we leveled up our Pokemon. Remember when we did Pokemon level plus equals 1? We could have done level equals Poke level. Level equals plus equals 1, sorry. Plus equals 1, then Poke level. These two things are the exact same thing. So hopefully that's intuitive. So I'll be moving on. And I'm actually just going to print out how much damage has been done here. So I'm just going to say Poke2 name dropped to health. So first, I'm printing how much damage has been inflicted by which Pokemon with which move. And after I deduct the health from the enemy Pokemon, I print out to like which Pokemon drop to which amount of health. And that's pretty much all our attack function needs to do, attacking one Pokemon with another. And just calculating the damage and deducting it from the health. We don't need to do this twice in the same function. We can just use the function twice. That's the magic of functions. They just organize and clump things together that belong together. Had to add a few seconds delay. I'm gonna do this at the end actually. It wasn't planned, but I understand why you guys might want to do that. So I'm just gonna make the functions first and then I'm gonna show you how to add delay, okay? So to sort of simulate a battle, because attacking isn't a battle, attacking over and over is a battle. To simulate a battle, I'm just gonna make a function called fight, okay? It's gonna take an arbitrary amount of Pokemon, okay? And using my sample function, the sample function, yeah, I'm going to override this variable with a list only containing 2 Pokemon from this arbitrary amount of Pokemon. So you could pass as many Pokemon as you want in this function, but only 2 randomly selected Pokemon will participate. Again, adding into the randomness of our program. So not only do you get different outcomes with each battle between the same Pokemon, but if you are willing to go ahead and define new Pokemon, you also get new Pokemon fighting with each other, and you don't know which ones. Just a little bit of a fun addition. Okay, you don't need to think about what's going on here. If you're curious, this function just picks this amount of random elements and stuffs them in the list, and then just returns the list. This function actually uses choice internally. But I digress. So here we end up having 2 Pokemon. So we need to fetch those out. So Poke1 equals Pokes0 for those who attended the, I think it was the last or the tutorial workshop before that. How we fetch elements from a list is with indexing, and indexing starts at 0. So the first element of our list is at index 0. And Pokemon 2, which is the second element, is at index 1. So there we go. From the arbitrary amount of Pokemon that we started with, we now have the 2 Pokemon that we can have fight each other. And how I'm going to do this is in the same way that we formulated this battle in the last workshop for those who participated. I'm going to use a while loop that just breaks out when a Pokemon drops below a certain amount of health. If one of you guys is like confused about the whole loop thing that I'm going to do right now, just what's the end of the last workshop? And I promise it will be so easy to understand what's going on. If someone is still completely lost in this moment, just ask me and I'll try to sort of explain what's going on. But what I'm going to do here is I'm going to have Pokemon 1 attack Pokemon 2. And I'm just going to check. If Pokemon 2's health is below or equal to 0, it's going to print Poke2 name fainted. Poke1 name wins. I'm just going to break out right after. So I'm just going to end the loop. So what I'm going to do is I'm going to copy paste this, which is not good practice, but it would take way too much fiddling around with variables and loops and stuff to prevent copy pasting, which is just not worth it for what we're trying to do here. So I'm just going to copy paste this. I'm just going to change up the 1s and 2s on my variables. And before each attack, I'm going to print a few hyphens just so we know when an attack is occurring. So we can like have a clearer picture of the attacks in the console. And at this point, all you need to do to simulate a battle is simply call the fight function with your two Pokemon that you've created before. With this and this, I'm going to use my actual fighting against my Milotic. Let's just run and see what kind of errors I get. I don't. So in my case, the Milotic won. Let me run again to see the actual one this time. My Milotic dropped to -8 health after I actually used Tail Whip for 24 damage when Milotic had 16 health. And if you keep running it, different moves are going to be used, so you're going to see different amounts of health and damages in different orders. In fact, if you want to randomize this more, you can use the randint function from the random module and sort of alter the calculated damage a little bit at random. You're getting a never-ending loop. Well, are you breaking it out when something drops below or equal to 0 health? Are you sure you're deducting the health properly according to the damage? There you go. You got a breakout. And remember how I said you can have an arbitrary amount of Pokemon here? Let's make another Pokemon. Let's make Pokemon 3 after we've defined everything. It doesn't matter where you define it, really. Let's give it a name. What's a name? Give me a Pokemon. I don't know Pokemon. Someone who knows Pokemon, just give me a name. Anything. Kanye West. All right, you know what? Let's make a Pokemon called Kanye West. What's its attack? How strong is it? From 0 to 1. .9, that's really strong. Okay. You know what? I'm literally gonna write 0.9. And how buffy is it? Beefy. How difficult? Come on, that's so. Okay, if it's so strong, we have to sort of counter it with. Okay, fine. And how much health does it have? Our other Pokemon had 120 and 136 health. 260, 95. I'll take 95. And you know what? Since we gave it, no, I'll give it 260. Fine. And since we gave it like that much attack, that much defense, and that much health, let's just give it like weak moves, okay? So what's one move? Give me one of its moves. Okay, Rap Battle. And what's the power of that move? Let's make it a little bit small. So things that we had before is 32, 42, 23, 51, so around 30. What's this one? 25, that's too strong in this case. Okay, 10. Give me another one. Another one. Anything. One more move. Confusion, hell yeah. What's the power on that? Can be a little bit stronger than Rap Battle. That's okay. 15, just a little bit stronger. So what I can do here, if I want only Pokemon 1, so this is our Pokemon, it's Kanye West, we're done. So if I want Pokemon 1 to exclusively fight against Pokemon 2, I can leave this as is. If I want Pokemon 1 to exclusively fight against Pokemon 3, I can do this. But I want 2 Pokemon from a pool of Pokemon to be able to fight. So I can just pass Pokemon 3 because I've modified my function to be able to take an arbitrary amount of Pokemon. And then from that arbitrary amount, it selects 2 random ones. So let's just run the program and see if we get Kanye West to fight. Whoops. Oh, shoot. Okay, sorry. Oh shit, it's Kanye West. Nice. So let's see how this fight went. It actually took a long time because Kanye West has so much health. So it took so many attacks from Axel to just chunk him down. And Axel actually managed to drop him down to 101 health. So I think Kanye West is still a little bit too strong. Let's just give him like 5 here and like 7 here. Axel won this time, dropping Kanye down to 5 damage. Let's see, does Kanye have any? Oh, so it was Kanye against Melodic here. Okay, so it was Axel against Melodic. Again, Axel against Melodic. Kanye West doesn't seem to be able to win with those stats. Damn, okay. You know what, let's make him a little bit stronger. All right. 7-9, all right? Nope, he lost again. That was Melodic Axel. Melodic Axel. Damn. Kanye West wins after like what, 20 attempts? He lost his confidence. Hell yeah. So so this is how you can sort of dense down a whole project into a single function, because that's how we did. Everything that we wrote here in our creative time section got densed down into a single line of code by using functions. And in fact, in the fight function, we're using attack over and over and over and over. If you didn't use a function and you literally copy pasted all that code, and especially if you didn't use loops, then you're looking at, like, this whole thing took us what, 50 lines of code. If you didn't use functions or loops, you're easily looking at 1,000 or 2,000 lines of code. What do you mean couldn't write here and follow your own description? Oh, my description. Sorry. That's okay. That's okay. I just gave like the. Okay, this was the sort of simplest and fun example that I could come up with, but obviously you can come up with your own implementations. You can sort of remove the whole random thing like completely. But yeah, this is the power of function, sort of using attack so many times, and within attack using calc damage. So if you follow the flow of the program a little bit, that's okay, that's okay. I went a little bit fast on purpose because we're sort of running out of time. I'm going to post all this code so you guys can just copy paste and sort of fiddle around and change things up. But before we finish, what I want to emphasize is how deep you can go with functions. So this whole thing is considered a quote unquote project, right? A 50-line long project. And we start with the fight function, which gets us here. And we would have a function call here. It's not our function, but it's still a function call, which is sample. And then we call attack. And within attack, we call choice, and then we call calc damage. And within calc damage, we call round. And this exits. We have a damage here. Our attack also exits. And then we go and call the next attack. And again, this leads us to getting damage from calc damage, which uses round, and exits, and then we look back and we call attack again, which calls calc damage again, which calls round, and you sort of get that nice stack of functions going in and out of each other in this elegant way. Well, it doesn't look elegant in the way that I wrote it, but the way it works is a little bit elegant if you think about it. We definitely avoided copy pasting a lot of things, because instead of attack here, what I could have done is could have literally like wrote this whole thing right here, here, and here. And already you can see how cluttered one function can get without abstractifying repeating these functions into other functions. Yes, normally you never want to copy a bit of code twice. As a rule of thumb, if you find yourself coding something and copying code, rethink how you're making whatever you're making. Yes, exactly. It's like instant ramen. I'll just go with that analogy just because it sounds tasty. Anyway, so that's that. That's functions. And I think we're actually exactly in time. Thank you all for participating. I really hope we shed light into the quite complicated topic of functions. If you understood most things, I applaud you. Krimineko, if you think this was the most interesting lesson yet, yeah, I'm not gonna spoil it. Just definitely make sure you attend the next few tutorials, because we're gonna be going into some really cool things. We're gonna get rid of the peasantry that is dictionaries for representing data, and we're gonna go into class and things like that. Thank you guys for participating, honestly, and thank you for chiming in when I asked for like Pokemon names and stuff, because I wouldn't be able to build all this by myself. Most of it was at the top of my head. I'll stick around for those who have questions regarding whatever we spoke here, or if you have questions about Python in general, how things work. I'll be here. Just ask me. I'll stick around for 10 to 15 minutes maybe, until I'll stick around until it's o'clock, whatever time you are, o'clock, which is about 12 minutes. Take care, bloke. See you next time, hopefully. Take care. Bye, Tarkus. The next session is on Saturday. But we actually hold 2 sessions every weekend, Saturday and Sunday. So if you're asking for when the next session in terms of time is, that's Saturday. The next session in terms of content, that's Sunday, probably, unless people want us to go over the last or this tutorial again. I call it a tutorial. It's not a tutorial. It's a workshop. I'm guessing you're asking for like, when am I going to get to learn more? The answer to that is next Sunday, hopefully. Did I say tomorrow? I didn't say tomorrow. I said next Saturday or Sunday. Tomorrow is nothing. Tomorrow is a weekday. Yes, we hold workshops during Saturdays and Sundays. It's usually different topics or different sort of levels of topics every Sunday or Saturday. Oh, no, yeah, don't just because I've worked with TB doesn't mean that we'll always be working together. Sometimes you'll see TB with someone else. Sometimes you'll see me with someone else. It just so happened that we're both available and willing today. Sometimes you may see me teaching the Saturday sort of workshops as well. So that's that. You have a wonderful day. Take care. Again, I'll be here for like the next 9 minutes for absolutely any Python questions whatsoever. Okay, it seems like most left. It's only me and 3 other people here. So if there are no questions, I guess I'll just chime out at this point. Take care, Hamstripe. All right, then I guess we can end.